In this video, we shall learn how to use R in order to fit a linear fixed effects model. Now in R, there are two different functions in two different packages that may be used. The first one of them is LME, which is found in package NLME, and the second one, the more recent one, is the function LMER in the package LME4. Now, while this is the more recent package, it is also the more unstable one and is less feature rich. And what is most important, both these packages are very badly documented. You will find some documentation on the web, something online, something coming with R, but all of them are extremely incomplete. The reason I personally prefer LME is because this is backed up by a book, which is this book, Mixed Effects Models in SNS Plus, written by Pinheiro and Bates. And these two people are the author of that NLME package, so it is sort of better documented than the LME4 package. This book is not a very well written book. It is a rather badly written book, but still it is better than the incomplete online documentation. So in this video, I shall be using the first one, namely LME from the NLME package. In many installations of R, this package is already there by default. If not, you have to install it by install.packages as usual. Our example will be our standard, the tablet example. So we have those 10 tablets. We have broken each one of them into two parts, measured the active content, amount of active content using two techniques, HPLC and NIR. Now our data file will be precisely of this form, so that is not suitable for running LME. So we have to think about that box diagram thing. So in this case, there are two inputs. One is method and the other is the tablet. So these are the two inputs that we have, methods and tablet. And the output is the measured amount. So since there are three arrows, of course we have the random arrow which I have not shown. And we have got three arrows, so we must have the data in three columns. In one column we will have all the tablet names. In one column we will have all the amounts. And in another column we will have all the methods. So we need to have a matrix which is 20 by 3. 20 because we have 20 measured things. That will be the amount column, followed by the method column, which will be HPLC 10 times, followed by NIR 10 times, followed by the tab thing, which will be basically 1, 2, 3, 4, 5, 6 up to 10, then again 1, 2, 3, 4, 5, 6 up to 10. So let's first do the processing of our data file. So let's first read the data. I have the file called tablet.txt. Let me just show you the file quickly. Tablet.txt is this file. It has got three columns, tablet, then HPLC, they're not very properly aligned, and NIR. And I'm going to read this and rearrange it in the form that is suitable for reading into R. So let's just do that. I'm reading it first. I have read it, so let's see what I'm getting. That's the data file that I got. Now I am using this line, dat1 equal to this. So that should not be very difficult for you to understand what is happening. What we are doing is we're working with dat. Then we are creating a new data frame, and this data frame has the following columns. AMT is the amount which I am producing by concatenating the HPLC figures with the NIR figures. Follow it up with another column method, which is basically 10 HPLCs with 10 NIRs. Finally, that is followed by a column called tab, which is basically 1 to 10 repeated twice. So that gives you the final thing. So this is how I am producing this entire stuff. So let's just run that. So I've run it. Let's quickly take a look at that one, and it is of the format that I wanted. So I have amounts, all the methods, and all the tablets.